This PowerPoint will tell you about studying maths in context next year. Please feel free to pause it at any time. Although all students have to study maths at GCSE, relatively few students choose to go on and study maths beyond GCSE, and this means that many people don't necessarily have the mathematical understanding that they will need for work and everyday life. For example, when you're working, you will need to be able to check that your income tax and national insurance have been correctly deducted from your pay. When you want to buy a car, you'll need to be able to work out which is the cheapest way to borrow the money. As an adult, there will be many everyday situations that require you to use your mathematical knowledge. If you're watching this PowerPoint, then you'll be going on to study other subjects at level 3, whether as A-levels or BTECs. Many of these subjects have a surprisingly high math content, and if you don't extend your mathematical knowledge beyond GCSE, you may struggle with the maths content of your course. This is especially true if you did the foundation tier for GCSE maths. You can see how much maths there is in the A-level subjects on this slide. I haven't been able to find the percentage of maths content on the BTECs, but I would assume it would be similar to the content that you find in an A-level. One of our teachers, who has taught maths in context for several years, says that in her previous school, most of the A-level psychology students took maths in context and said that they found it really useful in helping them understand and cope with the maths involved in psychology. Similarly, there are lots of undergraduate courses that have a substantial element of maths content. You may go to university thinking that you won't need maths, but if you study anything that, for example, involves analysing data, you will need to have a greater understanding of statistics than you get at GCSE. The other thing is that it's actually really hard to know right now exactly what you want to do in the future. So having maths at a level above GCSE keeps a lot of doors open that might otherwise be closed. My own daughter did Spanish, French, psychology and philosophy and ethics at A-level, and then went on to do a bachelor's degree in linguistics and English, which is an arts subject. She then found that she was really interested in how brain lesions affect speech and decided to go on to do a master's in neuroscience. Not having done any maths since GCSE, she found that she had to get her head around analysing and interpreting statistics at post-A level in about 4 weeks. These days you never know where your studies or career will take you. Gone are the days of a job for life. Maths in context will definitely put you in a stronger position to take advantage of potential changes in direction. As it says here, you'll build on what you learned at GCSE. If you did higher tier maths at GCSE, you'll certainly find that you're familiar with a lot of the stuff that you do in maths in content. If you got your grade 5 on the foundation tier GCSE, you won't have covered all of the content that is on the higher tier, and you will need to work hard over the summer holidays to cover this content. You'll be provided with transitional work, and there will be more content that is new to you on the Maths in Context course. You'll only be eligible to do Maths in Context if you got a grade 5 or above. So about 1/5 of the content of the Maths in Context course will be above the higher tier GCSE standard. So this slide tells you a bit more about the statistics element of the course and talks about some of the industries where it's particularly important. I think statistics crops up in a lot of A-levels in some form or another and is used in a really wide range of jobs. Even as a teacher, I regularly use statistics to analyse data relating to exam results and so on. Probability will be familiar to you at a basic level. Again, you can see some of the industries where probability is used. Risk assessments are an important part of health and safety, and if you look at the school risk assessment for the further opening of schools after the lockdown, you will see it being used. Having a greater understanding of probability makes it much more interesting and easier to understand risks, whether that is in relation to the current COVID-19 situation or deciding whether you should go bungee jumping when you're on holiday. Linear programming sounds a bit scary and will probably be a new term for you, but it basically involves algebra and ratio. During the COVID-19 pandemic, I'm sure you will have heard the government ministers and advisors talking about modelling, which they use to inform their planning. They will have used modelling to plan for the economic impact of COVID-19, the loosening of the lockdown in terms of schools, shops and other establishments reopening, as well as the number of people we can see in our bubbles. Sequences and growth based on proportion and rates of change. You can see a very direct link here to the current situation with COVID-19. The government uses R, the number of people that each person infects with COVID, to produce the curve. If you look at the early part of the curve, you'll see that the number of people with the virus was increasing ever more rapidly because R was more than 1. Currently in the UK, R is less than 1, so the number of people being infected each day is gradually reducing. As you can see, there are 12 topics which provide the context for the math skills you'll be learning. The topics are really easy to relate to, both on a personal level and in terms of the other subjects you'll be studying. At GCSE you learn skills, but in maths in context you get to apply them to real situations, which is really good fun. The course pulls data from real situations, so you'll probably find that some of the data that we've been seeing in the COVID-19 briefings from the government will appear in future exam questions. You'll find that most elements of maths in context are involved in more than one topic, so you'll use many of the skills multiple times. This will help you to become thoroughly familiar with them and master them. So, for example, you might look at scatter graphs and correlation in many of these topics, just as you will use scatter graphs and correlation in other subjects you are studying. But it won't just be the describing correlation and as positive, negative or no correlation as you did in GCSE. You'll learn about how to measure the degree of correlation between two variables and decide if the correlation is causal, which means if there is a relationship between the two variables that is related to cause rather than just coincidence. You will have fun with these topics and may be surprised at how quickly you find yourself using the skills developed in maths in context in everyday life. You'll have 2 exams in the summer of year 13, but the exam board releases the source booklet in mid-April, which gives you plenty of time to study it and become really familiar with the data and content. You can make notes on your copy of the source data, although you can't take your own copy with any notes on it into the exam. You'll be given a clean copy with your exam paper. This slide gives you the UCAS points for each grade, along with the approximate grade boundary. You'll have a textbook with lots of key points and practice questions in it, similar to your GCSE textbook, but it's not nearly as big. You'll have your own textbook and you will take this home with you and be expected to bring it to all of your lessons. You'll have 3 lessons a week and we'll be doing green assessments roughly every 2 weeks or so, so that we can see how you're doing and monitor your progress. If you have any questions about maths in context, please email me. My email address is on this slide.